Good morning, good afternoon, good evening. This is a tutorial on the InterCredential architecture reference model, or InterCredential as they're known. The two primary features of the InterCredential architecture reference model is that it's layered and interoperable. So the agenda, we cover these points. In step 2 there, we're going to talk about raw credentials and the raw credential sender receiver model. It's a pickup from a few days ago, a bit of a review. Similarly, we're going to talk about verifiable credentials and the verifiable credential sender receiver model. We'll follow that by a review of the issuer holder verifier model. And once we get through those three, we're going to see in step 5 that there's a hierarchical taxonomy of credential receiver models at play here, which is quite interesting. And then we're going to look at two more scenarios: verifiable credentials with JSON-LD extensions, and in 7, the idea of alternative serializations. We're going to talk about something called structured credentials. We're not going to go into depth about what a structured credential is, but just understand that it's an alternative serialization. And then from that, we're going to actually deduce the Internet Credential architecture reference model and the concept of blood types. You can see the blood types actually to the right of each one of these agenda items. So this is what the Internet Credential or InterCredential architecture reference model looks like. Here's an identical version, except some of the components, the blood types, if you will, have been highlighted. So we talk about these as InterCredential profiles or InterCredential blood types, and of course only profiles with certain blood types can be used together from an interoperability perspective. So let's talk about raw materials and the raw credential receiver. So raw credentials in Web 7.0, the following terms are equivalent: a raw credential, a collection of properties where one of the properties is an identifier, a collection of attributes where one of the attributes is an identifier, a collection of named value pairs where one of the pairs is an identifier, a collection of claims where one of the claims is an identifier, or a collection of assertions where one of the assertions is an identifier. So you get the pattern here. You're able to choose whatever lingo you want, but ultimately all of these are synonymous and equivalent to the concept of a raw credential. There's the footnote at the bottom. A raw credential by definition is not a verifiable entity unless the credential has a verifiable proof associated with it. A raw credential by definition is not a verifiable entity unless the credential has a verifiable proof associated with it. So just a review, let's look at the raw credential sender receiver model. So on the right, we have the sender who's sending a raw credential to the receiver on the left. And if we look at the 3 steps to send a credential, on the right hand side there, we create the credential, we auth encrypt the message and a credential attachment, and we send the message. And we send that from the origin interface of the sender to the service endpoint of the receiver. To receive the credential, you receive the message, the incoming message. You decrypt it, you verify the sender, you detach the credential, and then you process the message and the credential through whatever workflow or business process is appropriate for the credential type. And then just bridging to the trust spanning layer framework, we can see that raw credentials are part of the trust spanning layer, layer 2. They're just as basic and common and as broad a technology as DIDCOM messaging itself. Again, let's review verifiable credentials and the verifiable credential sender-receiver model. So a verifiable credential is a simple extension, a simple baby step, if you will, up from a raw credential. A raw credential has a verifiable proof associated with it. Or when a raw credential has a verifiable proof associated with it, as well as some other metadata, the credential is referred to as a verifiable credential. All verified credentials are raw credentials, but only raw credentials that have an associated verifiable proof are considered verifiable credentials. And here the verifiable credential sender-receiver model is virtually identical to the raw credential sender-receiver model. We have one extra step on the right and one extra step on the left, so let's go through those. So to send a verifiable credential, we create the credential, we sign the credential, we auth encrypt the message and the verifiable credential attachment, and we send the message. So here, only step 2 is the additional step relative to the raw credential sender-receiver model. On the left-hand side, where we receive the credential, we receive the message, we decrypt it, we verify the sender, we detach the verifiable credential, we verify the verifiable credential, and we process the message and verifiable credential again through a workflow or business process, middle tier logic appropriate to the message contents of the verifiable credential. Here, the only additional step is step 9, where we verify the verifiable credential, and the rest of the steps are identical to those performed by the raw credential receiver. We also see in the middle there the InterCredential blood type, so VC for verifiable credential. Mapping that to the trust spanning layer framework. Verifiable credentials, the verifiable credential sender-receiver model, because it's based on the raw credential sender-receiver model, which is part of the trust spanning layer, part of layer 2. The verifiable credential receiver model is part of layer 3. The issue holder verifier model. So this is a depiction of the issue holder verifier model from Wikipedia, and we can see 2 applications here of the verifiable credential sender-receiver. So the first one, the issuer, is a specialization or a derivation of a credential sender, follows the steps that we've just outlined, to send the newly issued credential to the holder. The holder is a specialization or a derivation of the credential receiver. So much for the left-hand side, and we can see again the blood type is InterCredential type VC. Moving over to the right-hand side, the holder now is a specialization of the credential sender. The holder is going to create a verifiable presentation based on the verifiable credential data it received from the issuer, and it's going to send that presentation to the verifier. And the verifier, again, is a specialization or a derivation of the standard credential receiver in the verifiable credential sender-receiver model. And we can see on the top right corner there that the InterCredential blood type is VP for verifiable presentation. This is the only place where we're actually going to talk about verifiable presentations, and it's there for completeness. So where does the issuer holder verifier model fit in? Well, it's part of layer 3, the trust tasks layer, because like the verifiable credential receiver model on which it is based, or on which the issuer holder verifier model is derived, it naturally needs to belong in layer 3, and the verifiable credential sender receiver model, as we discussed earlier is in layer 3, because the most basic credential receiver, sender receiver model, the raw credential receiver model, is part of layer 2. So we're starting to see a series of derivations or specializations. So let's start to look at a hierarchical taxonomy of credential sender receiver models. So here we can see, starting at the bottom, we have the raw credential sender receiver model that we've just finished discussing. We can see that the verifiable credential receiver model is a specialization or a derivation of that raw credential sender receiver model. And at the top we can see that the issuer holder verifier model in turn is a specialization or derivation of the verifiable sender receiver model. So it starts to look fairly interesting, the ability to layer out in a hierarchical taxonomy the different types of internet credentials, the different types of InterCredentials, as well as the sender receiver models. Let's look at 2 more examples. The issue purchase order model. So here we have ABC Groceries wants to order a purchase order, or wants to order 10 cabbages from David's Cabbages, and it's going to do it by issuing a purchase order verifiable credential and send that over to David's Cabbages software agent, its order endpoint, if you will. Again, the InterCredential type is VC for verifiable credential. Here's our 4th example, issue vaccination credential. So it's almost identical to what we've seen on the previous slide, except it's a vaccination authority and Alice as the actors. And the vaccination authority is sending a vaccination verifiable credential from the origin of its software agent to Alice's service endpoint of its software agent. Again, the InterCredential type is VC. So how do these fit in to our hierarchical taxonomy of credentials and credential sender receiver models? Well, the issue purchase order model is just a specialization of the verifiable credential receiver model, symbolized by the blue line on the left. We have the issue vaccination credential model on the right, and it's symbolized by the purple arrow on the right, and we can see that really these are all synonymous in terms of them being specializations and derivations of the underlying verifiable credential model in the middle. The issuer verifier, holder verifier model, as we've discussed, is part of layer 3. The issue purchase order model is also part of layer 3 of the trust tasks layer in the trust spanning layer framework. And the issue vaccination credential is also part of layer 3. Verifiable credentials, we've already discussed, is a derivation of the raw credential sender receiver model in layer 2. So we've looked at 3 different scenarios now. Let's add another couple in here to reinforce this idea of a hierarchical taxonomy of credential sender. So here we have verifiable credentials with JSON-LD RDF extensions. So Alice is sending one of these JSON-LD RDF verifiable credentials from Alice is sending that over to Bob. We can see the InterCredential type is LD VC1 and LD VC2. There's actually 2 variations there. And we'll talk about that more clearly when we get to the InterCredential architecture reference model. Structured credentials. Just think of structured credentials as an alternative serialization, an alternative shape for the credential. And so it has a blood type of SVC for structured verifiable credential. And if Alice wants to send those to Bob, it's the same sender-receiver model. It's the sender-receiver model as a verifiable credential. So let's add these into our hierarchy. Well, the verifiable credential with JSON-LD RDF extensions is, again, just a specialization or derivation of the verifiable credential sender-receiver model. And on the right-hand side, the structured credentials alternative serialization, again, is just a specialization or a derivation of the verifiable credential model. So all four of these colored models, and the fifth one being the issuer holder verifiable model, are really just natural extensions, derivations, specializations of the verifiable credential model in the center, and the verifiable credential model in turn is a derivation of the raw credential sender-receiver model at the bottom. So we finally get to the Internet Credential or InterCredential architecture reference model. So whenever you're working on an architecture reference model, you need to figure out what are the dimensions that are going to be used to span the space, to describe the space of Internet credentials. So this is just an initial version. I think there's at least a couple more versions of this to be had. But the first dimension is, does the credential have a verifiable proof or not? So the example is it derived from raw credential with no verifiable proof, or is it a verifiable credential that has a verifiable proof? The second dimension is, does it have support for the JSON-LD RDF at context tag in the verifiable credential? That is, the credential is derived from verifiable credential and has at context JSON-LD RDF support. Number three is again a baby step in terms of elaboration of the architecture reference model. It supports both context, at context, and at vocab, JSON-LD RDF support. That means it's derived from a verifiable credential and has both of those tags present in the verifiable credential. Four is, as you will see, is the fourth column in the architecture reference model for InterCredentials, and it's on the horizontal axis, but it's really talking about something different, alternative serialization formats, and in this particular case, structured credentials. So what other dimensions, what other candidates are there for expanding the architecture reference model for InterCredentials? Different cryptographic suites, different automation, different types of authorization. There's probably several dimensions that could be added here. So this is what the InterCredential architecture reference model looks like. Again, we're going to look at this version, which is InterCredential profiles, or Internet Credential profiles, aka Internet Credential blood types. So starting in the bottom left corner is Raw Credential, the RC profile. So it has no verifiable proof, it has no at context, and it has no vocab. It has no support for JSON-LD RDF. It also is not verifiable because it has no verifiable proof attached. Above that is the VC profile, top of the first column. The only difference between that and a raw credential is that it has a verifiable proof associated with the credential. Moving one step to the right, we have the LD VC1 profile. So this is the first of two profiles where the Verifiable Credential has JSON-LD/RDF support. In this case, only support for at context. And if you look at the bottom of column 2 there, it says yes, no. So yes to supporting context and no to supporting vocab. If we look at the LD VC2 profile, or what I might call the DHS profile, this is a verifiable credential that has, again, more complete JSON-LD RDF support. And to some extent, you could, when it becomes kind of so niche in meeting the needs of a particular group of applications, you could consider it a private profile. And at the bottom of layer or column 3, you see yes, yes for supporting both context and vocab. On the right, again, in column 4 are the structured raw credential and the structured verifiable credential. Structured credentials is an alternative serialization, alternative shape, if you will. So it doesn't really fit on this. Technically doesn't fit on this horizontal axis of JSON-LD RDF support, but the idea of structuring using an alternative format or shape for the credential fits naturally in here as column 4. So the Internet Credential or InterCredential architecture reference model is proposed as an overlay on top of the existing Verifiable Credential Data Model specifications. The InterCredential model is not intended to be a new Verifiable Credential Data Model specification, only an overlay. Although I think there's still the opportunity, depending on how many people become involved and how much effort we want to invest, it is possible for it to become a new standalone standard as well. Because the InterCredential architecture reference model spans so many technologies, a number of different standards organizations, a number of different specification documents, I've coined the name poly-specification. So the InterCredential architecture reference model is a poly-specification. It spans verifiable credentials, it spans DIDCOM, it expands the trust spanning layer framework. 3 specifications in development, 3 different standards organizations. So an interesting question, where's the best place for the InterCredential poly standard to be incubated, birthed, and nurtured? Is it the W3C? Is it DIF? Is it TOIP? Is it someplace else? Is there a new foundation that's needed for poly standards? TBD. Interoperability. Just a final note on interoperability. Lots of discussion around interoperability. So my view is that a niche specification that only interoperates with itself is not a useful definition, example, or showcase for interoperability. The true test of interoperability is the ability to interoperate across multiple credential formats, multiple protocols, and multiple transports. That, again, any niche specification that only interoperates with itself is really not that interesting. So that wraps things up. If you have any questions, you can tweet those questions to Freddy Architect on Twitter, and I'll be sure to answer them. So thank you for spending this 25 minutes watching this presentation on InterCredentials and the InterCredential architecture reference model.